Do it, please. Are you checking your email?
Yes, sir.
Yeah, you got the score.
Yes.
So you got the feedback also for each of the questions, the feedback I gave. You got that one also, right?
Yes, sir.
So now everything is clear to you.
Yes, more or less clear.
Yeah, it should be clear. The way I gave you the feedbacks, it should be clear. Even after that, if you have any doubts or any confusion, any queries, tomorrow we will discuss, okay? In our class tomorrow, we will discuss at the beginning. Today, you just check it at home with your time.
Yes, of course. Okay, sir.
Concentrate, take your time and try to understand it. I think you will understand. All of you can understand what to do. Where is your mistake and how to write the answers. You'll understand it. So did you see today's posting, class posting, which topic we are going to discuss? Hmm? Did you check it in the messenger group or in your G class? Every day when I give you the link, there I mention what we are going to discuss today. So what I gave today, can you check? Hmm? Hello?
Sir, can you repeat again? I couldn't hear you.
Okay, I said that every day when I give you class link, I mention what we are going to discuss today. So did you check it today?
Okay. No, sir.
Please check and you find what is the topic we are going to discuss today. Let me
Mass,
know.
weight, and density.
Yes,
Topic 4,
yes,
mass, weight, and density.
yes. So you check it. Always you check it. When I send you,
I actually came here in a hurry, so I didn't get time to check it.
you came in a hurry. Okay. I sent it in the early morning today. In the early morning,
Didn't check it at that time.
I sent it in the early morning, so you could check it that time.
Excuse me, sir.
Yes, yes.
Can you hear me? Because there was some problem with audio in my device earlier today.
Yeah, it's
So,
very
can
clear.
you hear me?
Your voice is very clear. It's okay.
Okay, sir.
It's really good. Your voice today, even better than other days.
Yes, it's clear.
Yeah, isn't it? Her voice is better than other days. I found.
Yes.
Syed Taki is coming. So here is the note.
Hello, sir.
Yes, how are you? Taki, right? Taki?
Fine, sir. Yes, sir.
Why you are late to join, Taki?
Sir, I was a bit busy.
Busy. Busy person. You are going to businessman. Busy person.
No,
So what you are going to be? Free person.
no,
Free man.
no.
don't want to be busyness man, you want to be freeness man, right?
None of them. I
Okay,
want
can
to
you
be a
read?
normal man.
Yeah, can you read please from here? Learning outcomes. Topic 4, mass, weight,
Okay,
and
sir.
density. Yeah.
Candidate learning outcomes. Candidates should be able to A. State that mass is a measure of the amount of substance in a body. State that the mass of a body resists change from its state of rest or motion. State that a gravitational field is a region in which a mass experiences a force due to gravitational attraction. Recall and use the equation weight equals to mass into gravitational field strength. E. Explain that weights and therefore masses may be compared using a balance. F. Describe how to measure mass and weight by using appropriate balances. Describe how to use a measuring balance to measure the volume of a liquid or solid. H. Describe how to determine the density of a liquid of a regularly shaped solid and often
Okay.
irregularly shaped solid which sinks in water. Define density and recall and use the formula density equals to mass by volume.
Okay, you know this formula before, right? Density equals mass per volume.
Yes, sir.
Yes. So what is the SI unit of density? If you know the formula, you can also find the SI unit, right? Hello.
Yes, sir.
Yeah. So if you know
You
the
just
formula,
ask anything.
yeah, I asked that if you know the formula of density, you can also get the SI unit.
I couldn't hear you actually, that's why.
Okay, now you tell me.
Kilogram per meter cube.
Yes, kilogram per meter cube. And you did it in class 7, isn't it?
Yes, sir.
And
We learned two
if
units,
you
one is
go
gram per
through,
centimeter cube and kilogram per meter cube.
yeah, if you go through all the learning outcomes, you will see that almost everything is familiar with you, right?
Yes, sir.
You know what is the definition of mass. You know what is the formula of weight, isn't it? And for measuring mass and weight, we are using balances, right? Newton meter, you know that. Then for measuring density of irregularly shaped object, you are using water displacement method, right? Isn't it? Hello.
Yes,
So,
sir.
so these are familiar with you. It's not a difficult topic. It's very easy topic for you. Only few things we are going to add here. That is, with the definition you know before, the definition of mass, we will get another definition of mass related to inertia. Inertia, we are going to explain what is inertia. Then Batsha is joining from another device. Batsha,
No, sir.
Batsha, there are
One device only, sir.
so left.
Another one is fake, maybe, sir.
Yeah, your same profile picture, the same way another one just came. Then when I asked Batsha, you are joining again, then he left. So
Oh,
it's your copy, right?
yes, sir.
Your clone.
Wannabe Bakshas.
Okay. Now look here, Syed Taki. Another Syed Taki or the same Syed Taki? Okay, Syed Taki is coming. Syed Taki. Okay, only one Syed Taki. Okay, fine. Now, you see the definition of mass is given in the first learning outcome. Mass is a measure of the amount of substance in a body. So, what is the SI unit of mass?
Kilogram.
Kilogram. Okay.
kg, sir.
Kg. And do you know any other units of mass?
Grams.
Yes, sir.
Pounds.
Grams. Then pounds, right?
Ji, sir.
Yes.
So these units also
Yes.
you know. Then you know tons, heavier
Yes,
things,
sir.
right?
Yes.
Okay. Okay. So you have to focus in only SI unit, right? The other units we will need some time, but not always. But we have to know the SI unit. Now another definition of mass will come. Before that, we are going to discuss inertia. What is inertia? Batsha, you,
Yes, sir.
for example, you and Taki, huh? Both are standing in a place. Then Anmol is trying to push with the same amount of force. Once, once you and another time Taki. Then what you will observe?
Yes.
You when Anmol is trying to push you, Basra Fahad, that time you see
Yes.
Anmol is facing a very tough time, right? He's experiencing very tough time. He needs to
Yes.
apply too much force to move you. But when he's going to push Taki, he does not require that much force, isn't it? Isn't it?
Yes,
Yes.
sir.
So why it is? It's happening because you have more mass and
Then Anmol.
your mass, yeah, not only Anmol, if you compare with Taki, because Anmol is applying force on both of you, that's why you will consider with you and Taki or compare with you and Taki. Okay, so Anmol, when he wants to push you, then you are resisting his force, right? Because you have more mass, isn't it? Isn't it?
Yes, sir.
Yeah, and
Yes, sir.
if you think of Taki, uh, he's not applying that much resistive force on Anmol as he has less mass. So the tendency of this object, of any object, not only you, for any object, is tendency to stay in its place, right? That's why uh, we cannot move them so easily. And this tendency of the object is called inertia. Is it clear to you?
Yes, sir.
So,
Yes.
like you, if you want to move a table, a very heavy table with a higher mass, then it's very tough for you to move it, isn't it? And if you want
Yes.
to move a book, a small book of 1 kg, you can move it easily, isn't it? So why it's
Yes, sir.
happening?
Sir.
Because the table is more heavier, it has more tendency to stay in its place. And the one book, it has less tendency to stay in its place. So inertia depends on mass. If the mass is more, then inertia is more. Is it clear? Is it
Yes,
clear,
sir.
everyone? Now, Basra Fahad, you read here inertia, what's written. Can you read
Inertia.
loudly? Hmm.
Okay, sir.
You
Inertia is the property of
don't say Shia. Say inertia. Inertia. Huh? This way.
inertia. Okay.
Hmm.
Inertia. Inertia is the property of a mass which resists change from its state of rest or motion. The
Hmm.
inertia of an object refers to the reluctance of the object to start moving if it is stationary in the first instance, or the reluctance of the object to stop moving if it is moving in the first instance.
Hmm.
When a
Okay.
body of matter is stationary, it needs a force to make it start moving. The bigger the mass, the bigger the force needed. We say that masses have inertia, a reluctance to start moving.
Okay. Hold on. Now you have this definition. What is called inertia? Please write this. You write the topic
Okay.
name first. Everyone. Topic 4, mass, weight, and density. Write today's date. Then you write the heading inertia. Then write this definition. Huh?
Can you repeat again?
Yeah, I am repeating. You write the topic name, topic 4, mass, weight, and density. Then you write today's date. Today's date you have to write. Then write inertia. This heading you write inertia, and this definition you write. What is written here?
Okay, sir.
Do it fast. This definition, okay? Please do it quickly.
So finished.
Okay, now we are giving another example. The example I gave you, that is only for the objects which are stationary position, right? But our
Yes.
definition not only saying about the objects in rest, they are also saying about the object in motion, isn't it? So, object in motion,
Yes, sir.
that has also inertia. How it is? Like you are playing football, okay? And when you are playing football, someone is kicking or passing the football to you, then you have to stop it, isn't it? You have to stop the ball, or you have to, you know, get the ball, make the change direction with a small force. So when you want to stop it, uh, that time you have to apply some force, isn't it?
Yes, sir.
Isn't it? The ball is coming to you, like Badshah Fahad, uh, if you are a goalkeeper, okay? If you are a goalkeeper
Yes,
and
sir.
striker is uh, giving you a goal now, and he kicked the ball very hard, then you have to stop the ball, isn't it? With high force. That time the resistance you are facing, if another striker is giving you the ball with small amount of force, okay, then what you'll find, then you can stop it with less force, isn't it? Hello, hello.
I didn't understand.
Yes, sir.
Okay, so in the motion also there is inertia. I'm giving you another example that will make you understand more clearly. Like Lamisa, you and your two other friends are playing, yeah? And the playing is like that. You are standing at one corner of the like one side. You in your school you have two sides, okay? Two walls are there. So your two friends are coming towards you, and you are going to stop them. Is it clear? Hello?
Okay.
Your friends are coming towards you by running. Huh? They are running with high speed and coming to you. One of your friends is with good health and more massive. Your another friend is like not that massive, uh, medium. Okay, so both are coming to you, one after another, and you want to stop them. With your hand you want to stop them. So which one will face more difficulties, the more massive one or the less massive one?
The more mass one.
The more massive one, right? So why it
Yes,
is?
sir, obviously.
Yeah, why it is?
Because it
Because
has
yeah,
yeah.
if it is in motion, the object is in motion, it has also inertia to continue in motion. Okay, the more massive the object, it has more tendency or more inertia to continue in motion. Is it clear?
Yes, sir.
Is it clear, Lamisa?
Yes, sir.
Okay,
Yes,
so
sir.
inertia can be in rest, inertia can be also in motion. Is it clear now, everyone?
Yes, sir.
Okay, so I think the definition is clear to you now. Now, could you please read it, Lamisa? Amount of substance, this part.
Matter is the material substance that constitutes the observable universe, and together with energy forms the basis of the objective phenomena. The basic building blocks of matter are atoms. The atoms themselves comprise of nucleus and electrons.
Okay, then continue.
Mass. The mass m of a body of matter is quantitative measure of its inertia, i.e., is for example, its resistance to a change in the state of rest or motion of the body when a force is applied. SI unit of mass is kilogram kg. This is scalar quantity. The greater the mass of the body, the smaller the rate of change in motion. Although the mass is defined in terms of inertia, it is conventionally interpreted as the mass m of a body of matter. Matter is a measure of its amount of substance in the body. Under normal circumstances, this matter does not change. Hence, the amount of substance in the body can be assumed quantitatively equal to its mass. If the amount of substance divides itself, we can assume that its mass is also changed. Mass can be measured with a beam balance or an electronic balance.
Okay, okay. Thank you so much. Now, we have here two definitions of mass. You write the heading mass. Please write the heading mass, everyone. Then you write this definition first. This definition you write first, and here you write the mass of a body of matter is a measure of the amount of substance. You give your slash. After writing amount of substance, you write particles or atoms or molecules. Okay, we can define it in any ways. If you write its amount of substance, its amounts of particles, amount of atoms, or amount of molecules in the body, all are correct. So this is one definition of mass. Another definition of mass you just got from the idea of inertia. So after writing the first definition, you write here or. You write here or. You write here or. Then after writing or, then you write this definition. And after writing this definition, You write it, huh? The greater the mass of a body, the smaller the rate of change in motion.
Finished.
Done. This one is also done. The greater the mass of a body, the smaller the rate of change in motion. After writing second definition, you write this. Huh?
Yes, sir.
That's
I
why.
finished writing that.
Yeah, that's why I gave you this arrow here. Look, the greater the mass of a body, the smaller the rate of change in motion. It's related to inertia. Then after writing this one, then you write the unit. Huh? SI unit of mass is kilogram. It's very important to know what is the SI unit of any physical quantity. Yeah, see, class 10 students came. Let us talk to him. Huh? His class is in 11:55. He came now. Azmain. Hello, Azmain. Azmain came. Azmain. He left. He left.
Sir, he left.
Yeah, he saw that he is uh, calling in the wrong number, right? Then he
Yeah,
left.
yes.
So finished writing.
Yeah, very good. Very good. Then you write mass can be measured with a beam balance or an electronic balance. This part you write.
Okay, sir.
Sir, finished writing.
Are you done, everyone?
Yes, sir.
Yes, sir.
So we are done with mass today. Huh? Now, in your previous class, you got the idea of gravitational field strength. Huh? So, what is gravitational field strength? To know that, you have to know what is gravitational field. Okay, so you read here, please, Adrita, gravitational field.
Gravitational field. A
Hmm.
gravitational field is a region in which a mass experiences a force due to gravitational attraction. A gravitational field is a region of space surrounding a body that has the property of mass. In this region, any other body that has mass will experience a force of attraction. All bodies near the surface of Earth experience gravitational attraction exerted by Earth. You experience weight on Earth due to the Earth exerting gravitational force on you. The formula to calculate weight is stated below.
Okay, look here. A gravitational field is easier for you to understand if you get one experience in your daily life. I think most of you got this experience in your life. you worked with a magnet, right?
Yes.
And if you are taking one magnet and you are taking one piece of iron, then like where you are sitting, uh, for example, now where you are sitting, you are keeping the magnet beside you, and you are keeping the piece of iron like 10 centimeters away of the magnet. Do you understand what I'm saying? Hello?
Yes.
No, sir, I couldn't
You
hear you.
you are,
Sir, I couldn't hear you.
yeah. For example, you are keeping the magnet beside you where you are sitting, and you are keeping the iron around 10 meters away from you. 10 meters. 10 meters means 1000 centimeter. Is it clear?
Yes, sir.
Hello?
Yes, sir.
Yeah,
Yes, sir.
10 meters means 1000 centimeters. So it is a little bit far away. So what you will observe, the magnet is attracting the iron, piece of iron. Is it attracting or it's not?
Most
What do you
likely
see?
not.
Or the distance is too much.
Yeah, distance is too much. That's why you are not seeing any force of attraction between the magnet and the piece of iron, isn't it? But if you are taking the same piece of iron closer to the magnet, what will see?
It will
You
get
will see
attracted to the piece of iron.
it's jumping, right?
Approximate.
The piece of iron is now jumping towards the magnet, isn't it? Did you see?
Yes,
Did you have this experience?
yes, sir.
Hello? So why it is happening? Because at the first first example you got, in that one, the piece of iron was outside the magnetic field, isn't it? The piece of iron was outside the magnetic field. Now, when it is inside the magnetic field, closer to the magnet, then it gets attracted, isn't it?
Yes, sir.
Hello? Is it clear? Now, similar to that, we have gravitational field.
Oh,
Similar to that, there is gravitational field. So, if you are inside the field, inside the gravitational field, then you will feel attraction. But if you are outside the field, then you will not feel that attraction. Is it clear now? Hello?
Yes, sir.
So this is the, I think, this is the explanation of gravitational field, and I think all of you understood. So please write this heading, gravitational field, and write only the italic part. Write only the italic part. Uh, Italic part means this definition completely. Huh?
Okay, sir.
Okay. A gravitational field is a region in which a mass experiences a force due to gravitational attraction. Is it clear now? Gravitational field is clear to you? Hello, everyone. Yeah. Now, today we will not continue anything more from mass weight density. We will discuss the other part in our next class. Now, we are talking about the test again. They who join late, for them, I
The writing
already,
finished.
yeah, I already sent you the test papers.
Yes, sir.
All of you,
But
please.
hi.
Yeah, the test papers, your script already sent, isn't it?
Yes, sir.
Please check your email and you will get details. And you will not only get your answer, also will get the feedback. Even if your answer is correct or incorrect, you will get
Sir,
all
I'm
the.
confused with the first question, sir.
You are confused with the first which one, MCQ or structured?
Yes, sir. MCQ,
But
sir.
individual
MCQ.
feedback is a little vague.
Which
I
one?
think.
MCQ, sir.
Yeah, I tried to give you
The
big,
first one.
and you match it, huh? You match with your answer.
Yes, sir.
If you don't understand not only MCQ one or any other answer, you check out, huh? You go through everything, each and everything you go
Sir,
through. If you have
can I ask you a question?
just 1 minute, if you have any queries, then please let me know tomorrow, huh? Is it clear? At the beginning of tomorrow's class, we'll have a little bit discussion on our test paper if you have. Is it clear?
Sir, it's a small question. It's not really that
Yeah.
important.
I am coming to you now. Yes, Lamisa, now you tell me. Yes, please.
Who got the highest?
I think so far I can remember the highest mark is 18, and Adrita
18th,
got
sir.
that. Yeah, Adrita got that.
I got it.
Mashallah, sir.
Okay. So is it
Yes.
clear? Any more questions?
No, sir.
Any more questions, please? If you don't
No.
have, then we are stopping the class here. Thank you all for joining the class. Have a nice day.
Sir.
See you tomorrow. Okay. Allah
Bye,
Hafiz.
sir. Assalamu
Bye
alaikum,
bye,
sir.
sir.